Hey, what's going on, guys? Let's do this problem right here. We have integral of dx over x square root of 5 minus x square. Let's see how we can integrate this one. So first of all, if you see the bottom, this is 5 minus x square. But when I look at this reminds me something like when we have a square minus b square, we take a sine theta, right? And then we have, like, let's say this x square, x value, and this is a number, right? Ax square minus x square, we take a sine theta, and when we have x square minus a square, we take a sec theta, and whenever we have something like a square plus x square, we take a tan theta, right? So this is how we do this. But this one, which pattern looks similar to this one? It's a number minus this one. So this one looks like this. So let's see how we can bring this number to a square. So first of all, I can write this one as dx over x, and this one, this 5 can be written as square root of 5 square, right? Minus x square. Now I can write this one in this pattern. So here I am going to equate x is equal to root 5 sine theta. So that's what I'm going to replace with x, and dx derivative of this one is going to be root 5 cos theta d theta. So let's write everything in terms of theta. Now I can write dx is going to be square root of 5 cos theta d theta. So this is going to be root 5 cos theta d theta, and in the bottom we are going to have x, that is root 5 sine theta, root 5 sine theta, x root 5 sine theta, and in the square root we are going to have 5 minus root 5 cos theta. No, that is sine theta because I'm replacing the x, sine theta square, right? And let's see what we have what happens if we square this. We will get square root of 5 cos theta d theta, and in the bottom we have square root of 5 sine theta, and the square we are going to have 5 minus 5 sine square theta. And in the, so whenever we have something like that, the first thing we try to do, we try to eliminate this square root. So let's see how we can do this. Square root of 5 cos theta d theta. I can already cancel these two, so let's get rid of this one. And this is cos theta d theta, and in the bottom sine theta square root of, I can take the 5 common, so this is going to be 1 minus sine square theta. And this one reminds me something, that whenever we have cos square theta plus sine square theta equal to 1, we can replace this one with cos square theta, so that will enable us to eliminate the square root, right? So let's continue this one here. So we have this one, so I can write this one as cos theta d theta over sine theta, and this one is square root of 5 sine square theta. Like, I can write this one as 5 cos square theta, right? I replace 1 minus sine square theta with cos square theta, and now I can take the cos square theta out. So this is also, I can bring the 1 over root 5 to the front, so it's going to be 1 over root 5 cos theta d theta sine theta over cos theta. Now cos theta cancels, we left 1 over sine theta, so 1 over root 5 integral of 1 over sine theta, that is cosec theta d theta. So cosec theta integral, you have to remember that is cosec cosec theta minus cot theta, ln cosec theta minus cot theta. So this is 1 over root 5 ln cosec theta minus cot theta plus constant, right? Now, but this is not our final answer because we derived theta from x. Our original function is in the x format, right? So we have to bring this one into x format. We took this one, x is equal to root 5 sine theta. So we have to, let's write sine theta. Sine theta is going to be equal to x over root 5. And if we put this one in a triangle, theta, opposite is x, hypotenuse root 5. And according to Pythagorean theorem, we know this one is going to be root 5 square minus x square in square root, and that is our adjacent. Now let's replace this all this theta with these values, x values. So let's write this one down. So first we have 1 over root 5 ln cosec theta. Cosec theta is reciprocal of sine theta because 1 over sine theta is cosec theta, right? Sine theta is opposite over hypotenuse. So this is going to be hypotenuse over opposite. 1 over root 5 over opposite x. And that's what I'm going to write here. Root 5 over x minus cot theta. Cot theta is reciprocal of tan theta. So 1 over tan theta. So tan theta is opposite over adjacent. So cot theta is going to be adjacent over opposite. So this is going to be 5 minus x square because root 5 square is 5. 5 minus x square over adjacent x. So we can write this one right here. 5 minus x square over x plus constant. So now I can take the x common and write the final answer. Let's write it in red color. So 1 over root 5 ln root 5 minus 5 minus x square over x plus constant, and that is our final answer. I hope you guys liked this video. See you next time.